And I'm going to, Laura, I'm going to just use the same presentation we did yesterday, pretty much, okay? I'm going to go through a little bit more. Well, let me see. This is the Lone Star presentation. I'm going to go through a little bit more of the actual data that demonstrates the fault.
Okay.
Okay, but well, this means more to Laura than. But anyway, so I live on well, let me start from the beginning. I moved into Cochran's Crossing in 1992 because I was serving a bunch of next accounts up here. And my home was built in the village, the community of Lake Point inside Cochran's Crossing Drive. Now you lived on Kingwood, so this map probably doesn't mean a whole lot to you. What's important about it is the third village that was built in the Woodlands. When Mitchell opened up the Woodlands for development, he started in Grogan's Mill, which is right next to I-45. Then he added a thing called Panther Creek, okay, which is just southwest. So he's building out toward the west and north. And we're just a little northwest of Panther Creek. What was interesting about the Cochran's Crossing is for the first two villages, Mitchell had this really environmentally sensitive design. You know, he was going to, this is interesting to you, I think. He was going to use an Ian McHarg design. Does that mean anything to you?
No.
Okay. Ian McHarg is a famous community developer or whatever. He did a lot of the land work. He had this idea of leaving the surface of the ground like you found it as much as you possibly could. So instead of having underground drainage, he used ditches. And he tried to just modify the natural contour of the ground as much as he possibly could. The idea was if the water stayed where it fell for a long enough time, it would be absorbed in the aquifer, you know.
I remember the Woodlands used to be one of my accounts when I was at Ogilvy back in the 80s. And all the boulevards had, prairie grass that was like waist high growing up in the middle of them. It looked like shaggy at the time.
Yeah, now they're bluebonnets.
Yeah, that was one of the factors in my decision to move to Kingwood. Kingwood is, a lot like the Woodlands in that it's as natural as possible, but not quite to the same extent that the Woodlands was at that time.
Okay, well, keep all this in mind for just a second, because I'm gonna go into here's what my house looked like after 9 years. This is the year before my homeowner's policy was about to lapse. Okay, I bought a house. It faces north. You can see that the bottom of the page is in the north direction generally.
Okay.
Okay, so it's really kind of wrongly posed. You'll see that there's a point up here underneath that black box. It says R 0.0. That is the high point of my slab foundation. There's a diagonal then to the letter A, and that's the low point of my slab foundation. Over the first 9 years, I lost over 4 inches at point A. Okay, it was now 4 inches lower than 0.00. And this drawing was, this topographical drawing was done by EFI, which is the appraisers, construction appraisers that my homeowner's insurance policy brought to my house. They warned me that, this sounds to us like it could be geologic in nature. We don't do any geotechnical, we don't support any geotechnical shifts. If there's a water leak underneath it, we'll cover it. But we're going to use whatever we find against you if it's not water leak. Just be mindful of that. And so I had nothing to lose. So I had them come out and do this work. Now, my house, I decided not to do anything about it then, although I could put a tennis ball in the middle of my floor and have it roll downhill.
Jesus.
If I put it up there near that 2.5 inch mark, it would roll right down toward point A aggressively. Wow. So I is this big enough? I can put it full screen if it's hard to read.
Yeah, why don't you go full screen?
Okay.
I'm half blind.
Okay. Is that any easier?
Oh, that's much better. Yeah.
I'm so sorry. I did. Okay. I apologize. So here's that same kind of configuration, except that what I've got here now is just a general contour. The shape of the descent from 0.00, you can see it going down to about -4 inches at 2001. By 2006, it was going down 6 inches. So in that 4 years, I lost about 2 inches. In other words, it's dropping about a ½ inch a year. That's an important number. I'll show you later. My house was built in, at the little table over here. You can see that the year that I did the measurement, my house was built in 92, and I assumed that the cumulative drop at that point was 0. In 2001, I showed you with the previous chart that was about 3.8 inches. At 2006, it had dropped another 2.2 inches and was now cumulatively 6 inches. In fact, when I raised my house, you can see what happened in this drawing down below. The front step in 1992, every house in my community, the sidewalk comes up to just under that top set of bricks, within a ½ inch.
Yep.
By 2014, my house had been raised so much that it was almost 10 inches or 11 inches below where it started. The sidewalk was. I had to add a whole nother step because it would have been illegal not to, to have a step that large anymore, have us over a foot, have to step up over a foot from the sidewalk onto your front porch.
That would be a surprise if you stepped off of that.
Well, you can see in this, you can see why I became very interested in what was happening to my house.
Oh, yeah.
When I had my house leveled in 2006, I had a very good foundation engineer do the design work. We did 20-foot soil borings on the high side and low side, and was up above 0, and down below 8. Didn't find anything but sand, just sandy soil.
Yep.
We did find about 5 feet down a real thin seam of clay, which we were hoping would be enough to adhere and support the 20 feet plus of pilings that it took to raise my house to level.
Jesus.
It was done by Due West. I had them tunnel underneath the house. And they put most of that, the garage, and almost all the left side of the house and the staircase over that you see was all on 20 feet of pilings.
By the way, I don't want to interrupt your flow here, but I've got a similar problem. The side of my house that faces that fault has been elevated twice since I've lived here.
You not only have a similar, you got probably exactly the same problem.
Yeah.
You'll be interested. Well, let me take you through the rest of this narrative. I think you'll find it interesting, really interesting. And I believe you're a candidate for a cause. Let me show you. So I had no idea about what was going on. They told me this was poor lot preparation by my builder. My builder instinct was George Mitchell's architect's son, Scott Mitchell. He was one of the developers of this little community I live in. He designed all the houses. But when they started to lay, you're familiar with what the GRP pipeline is?
The what pipeline?
The GRP pipeline.
No,
the groundwater replacement pipeline.
And groundwater reduction plan, and it is a division of the SJRA, and they are the division that laid the pipes in 2015 to deliver surface water from the Lake Conroe to the woodlands. And
okay.
So all the GRP does.
Yeah, I'm sorry. I should have introduced that type of. No, it's appropriate here. So we found out that San Jacinto River Authority was about to put a pipeline running clear down the middle of Cochran's Crossing from west to east. And this was a big hulking pipe, 42 inches as it crosses in front of my house, or near my house. And when they published the pipeline, part of the plan was to compensate for potential faults in the area. Well, they hired a company called Fugro who did the original geotechnical work for the Lake Conroe Dam. They're an international firm, very well known. They're among Cadillacs in this business. They did the Egypt fault. They were not allowed to do the lower area. They had run some run-ins with Woodlands Land Development Corporation early on because they told them about 1993 that they suspected that there were several faults running underneath the communities that they were developing. And I'm not sure why, but the Woodlands lost confidence in them at that point, and they were let go and never to be rehired again, which is why but they were kind enough in this original report to include this map. And the area I want to point you to is this area of interest down here. I've just blown it up a little bit. And you can see there's a street called College Park Drive to the north. The SL 15, 16, 8, 19, those are what's called Scarp Locations. This is the high side of the fault. This would be like somebody coming in and put a marker on your wall and say that's probably where the scarp is because it drops from here down. So the scarp would be the high side of the fault. Now, you know which is the low side of a fault in this kind of diagram because the little triangles point in the direction that's dropping. Follow me?
Yeah.
Okay. When they published this map, I could see that my house was just right in a line of that Scarp Location 16 down there. I lived on the Panther Branch Fault. See where my home is? Panther Branch Fault. If you go beyond my house, this map would take that fault right down to the Woodlands High School.
Mm-hmm.
Okay.
So you're saying that when Fugro came out, they thought the fault ended where the green SL16 is.
That's as far as they could trace it.
Mm-hmm.
Because remember I told you about Ian McCard Designs?
Mm-hmm.
Well, what the Woodlands was doing in those in Cochrane's Crossing that they hadn't done before was they had gone from this ecologically sensitive design to a conventional neighborhood design. Curved and graded streets, and basically let's bulldoze the surface, okay? And when the rain falls, let's let it run off as fast as we can. We don't like this open ditch business because we can't have as many houses per square foot and people just don't like the looks of it. So we're gonna go to conventional design, but that meant literally leveling all the ground. The neighborhood, see where my home is, that little kind of irregular area in there, that Lake Point, that was all built between 1990 and 1992. Fugro presented these findings to the Woodlands in 1993. So there was no surface evidence of faulting when I bought my house. And I had no notion of this until this map was published.
Mark, before we move off this, you have a little caption bubble there that says "My Home," and it points to the left of SL16.
Yep.
Then there's a green dot that I thought you said was your home that has another like big green arrow pointing to it.
Yeah, I just make, no, that was so in a slide presentation you really could see. My home is on that straight, it's not in the SL16. That I should get rid of that. I'm sorry, it's interesting. My home is actually just directly in a line. You can see where it crosses. Bent Grass is that third street down between Cochrane's Crossing, goes around. Research Forest is underneath it. And then there are three little cul-de-sacs. Mine's the middle one, and my home is where I pointed to.
Okay.
Right in line with Scarp Location 16, which is the big green dot, despite the lettering under it.
So the big green dot is the end of what was known as the Panther Branch Fault at the time.
It's exactly.
But your home is on an extension of that line.
Yep. Okay. If you were logically to project that line, it would cross my house, which I mentally did as soon as I saw this map. But if you then project it even further, it would appear to be crossing the high school parking lot. Now, before I go any further downstream on this, let me show you a general map of the faults in my area. In fact, well, this is a LiDAR image. LiDAR is a way of measuring, are you familiar with LiDAR?
God knows LiDAR.
Okay, great. So the yellow lines up there are faults that were detected using LiDAR maps from, I think, 2008 to 2001, 2000, I don't know the dates on them exactly, but you could see where the ground had shifted linearly by just comparing elevations above and below these linear structures. So you'll notice a couple things from this map. One is that the faults coming out of the Conroe Salt Dome, okay, stop when they get to College Station. That's that street above me where we'll go back to it in a minute. And they disappear when they hit the woodlands. The woodlands is right in this area, okay? You notice how you get to the woodlands, they stop. When you get to Spring Creek down below the woodlands, they pick back up again.
Okay.
So what is it about the woodlands that makes those faults disappear?
Hang on. Before you get to that, hold that thought. Is the LiDAR, are the fault lines detected by something that happens in one survey or over multiple surveys?
Generally, those are detected typically by looking at comparing the elevation, because you can get very, very good elevations resolution with LiDAR.
Okay, so
that's why they use it. So if you look at it in 2001, and then you see this happening in 2008, you probably, and it looks pretty linear, you probably got a fault there. And that's what those yellow.
So it is multiple surveys. Okay.
Excuse me? I'm sorry, again, Bob?
So it is multiple surveys?
Yes.
Okay.
Although I got a friend of mine in Louisiana specializes in doing remote sensing, and he does micro agriculture or precision agriculture.
Yeah.
And you can actually look and see lines of those things in a single shot if you're good at it. And you can mathematically analyze those things. These LiDAR images are based on real data points. Right. And you can go through and you can mathematically reproduce these from a single LiDAR image.
Yeah, that's pretty amazing technology. Okay, I'm sorry, I interrupted you.
No, you're not. But you understand now. You're beginning to see the picture. Yeah. Here is a paper that you probably, are you familiar with this paper, Bo Yang? Eco-hydrological planning for the woodlands, lessons learned after 35 years.
No, I'm not familiar.
Google, go out on the internet and Google this dissertation.
Okay.
It's very good. He's the one that brought to my attention the difference that the Ian McHarg design made in the woodlands. The original design, he shows that the streets and the lots were left at the same levels that they were found. This served to prevent runoff downstream and a lot. So what they were trying to do is to prevent a West Houston phenomenon where, a drop of rain hits in Katy and it's in Buffalo Bio before you know what happened. It just runs straight down the street. It's all concrete. Mm-hmm. None of it gets absorbed. And that's what they were trying to prevent with the post Ian McHarg in Cochran's Crossing. Totally different deal. We don't care how fast it runs down. And evidently, his dissertation basically shows that this may have affected some of the areas that were down in southern Grogan's Mill, which had early signs of flooding. So here's another LiDAR image. This is a closer in LiDAR image of just the woodlands. Now, I showed you earlier where Cochran's Crossing kind of roughly is. I talked about the faults coming down from the Conroe Salt Dome, and you can see the yellow lines turning to red up there by that little crooked street. That's College Park Drive or State Highway 242. When they get south of that, they're in the woodlands. And suddenly when you get south of that, they disappear. But we know that the Big Barn Fault, the Jones Fault, the Panther Branch Fault have all reemerged as active faults. Here's where Cochrane's Crossing is relative to those faults. Okay, so the fault, you can see underneath that, Bob, how precisely you can follow the paths of all the streets as compared to, look at the area southeast of that, how rolling and kind of almost blurry the topography is. But when you get to Cochrane's Crossing neighborhood, it becomes real crisp, which means you don't see the fault. The faults have been erased at that point. And we know from street damage and other things, we're able to kind of track these faults out. But that's why I've had such a hard time convincing the powers that be that the fault that I live on is part of a fault that crosses underneath the Woodlands High School. So what is important about my use of your time? It's to bring to the fore this problem. The fault that I live on, as I suspected, crossed underneath, it crosses the pipeline. It crosses right underneath the entrance to the Woodlands High School, okay? And you say, well, so what? Well, here's an example of what can happen when you have a water line near a school. This is UCLA campus in July of 2014. They had a 28-inch water line break underneath Sunset Boulevard that spewed a column of water 20 to 30 feet high and dumped 20 million gallons of water before they could turn it off.
Wow.
You know, you can't take a 28-inch column of water that's running 10 miles and just snap it shut all of a sudden when it breaks. You got to let that pressure go slowly as you slow it, that whole column of water. It'd be like trying to stop a freight train on a dime.
Right.
That's all that kinetic energy has to be handled, managed, or it'll blow the pipe out. So I would encourage, at some point in time, you might be interested in this. This is always a good predicate for me to explain the importance of my presentation. Is I thought there was a pipeline. So I convened in August of 2013, before the pipeline was laid in front of the high school, to the San Jacinto River Authority, to the county commissioner, and other powers that be. I predicted that there was a fault that would go from my house to a large crack in the parking lot of the Woodlands High School. Here's a photograph of the Woodlands High School. It's actually a Google map of the high school parking lot. You can go out yourself and Google Map satellite image of the west parking lot of the Woodlands High School, and you can see the same reproduction. It's even bigger now, but that was in 2013. So if you look at, remember Scarp Location 16 you asked me about?
Yeah.
My house, Big Grass Residence, the fault at the Woodlands High School. Remember the high school place mark up there in the corner, the little yellow pen?
Yep.
That's the yellow pen down here. Sure did seem to me like there was an awful lot of evidence that, particularly when you do a closer inspection of that high school parking lot, you'll see that it's a little lower on the west side. I hope I remembered to mention this to you early on, but of the three faults, the Big Barn, the Jones, the Panther Branch fault that all flow through Cochrane's Crossing, those are all part of a fault system that runs from the north side of the Conroe Salt Dome to the north side of the Tomball Salt Dome down to the north side of the Hockley Salt Dome. It's called the Hockley-Conroe fault system. And of these three faults, the Big Barn and the Jones are down thrown to the east. Okay?
Yep.
Mine is the only fault, well, the Panther Branch fault that I live on is the only fault in the Woodlands that's down thrown to the west. So it's kind of got its own signature. And that signature is pervasive at my house and at the parking lot of the high school. So I argued with these guys that I think that if you draw a line there in a number of years, you're going to see that is active underneath the pipeline that you're planning to put in. Well, they didn't exactly swallow my line, hook, line, and sinker. They, in fact, have the geologists that did the original geologic studies for the pipeline see a pipeline. Actually, I'm sorry, I should mention this because not familiar with it. The pipeline goes down that 2-lane highway right above the high school. That's Research Forest Drive. Yeah. Pipeline follows the southern shoulder of that all the way to the Highway 45, just about. They hadn't put it in yet. They were about to put it in, and you can see where the entrance of the high school is, or just to the right of that yellow pin down there.
So have cracks appeared in that double street there?
Have not yet. And that's a big part. That is the crux of the case against there being faulting, is we don't see any evidence of pavement damage at that intersection. Therefore, we think this fault is an anomaly. Okay, what you see in the high school parking lot is totally different than what we're seeing at Dr. Meinrad's house up there. So
one more question before we move on. Are they planning to bury the pipeline, or is this going to be an above ground pipeline?
They built it. They're not planning to. They already did it. They did that in 2014.
And they encased it in a sheathing, right? Some sort of.
Yeah. But no, in 2013, when I actually had them in my house so they could step into my house over that step in the front of my house, see the damage. I actually had them in my house, giving them almost this exact set presentation up to this point. Yeah. So this is why I think you guys ought to carefully look at that. Nah, we don't need to look at any fault line there. There's no evidence of a fault between. They agreed that the fault probably came down to my house, looking at the fault damage and everything else. But they disagreed that it crossed the pipeline where they were planning to put it in. Okay. So here is the report from the geology report, which guided where they identified active faults along the pipeline route. In summary, field and aerial photographic evidence indicates that only 2 faults. Now there are 3, but only 2 of the faults, the Big Barn and the Jones Fault, cross segment W2 of the San Jacinto River Authority pipeline or water line. Okay. Above that, they talk about the Panther Branch Fault approaching Bentgrass Place, which is the street I live on, but terminating before it gets any further south. No empirical data to support that, nothing. Just that he didn't see anything that disproved the null hypothesis. Mm-hmm. Okay, it didn't prove the null hypothesis, but it didn't disprove the null hypothesis.
And in theory, if you laid the GRP pipeline, you're putting South County at a level of 30% surface water. So you're reducing your groundwater withdrawals, and maybe even if you do have a fault, you might not activate it so much because you're reducing your groundwater. I could see an argument that so that there is a fault, we'll do what we can to shore up the pipeline, and the fact that we're building it is going to reduce any kind of subsidence. We're hopeful of that. And then, so in 2015, this pipeline was completed, and we saw that subsidence slowed, and we saw that the water table stopped dropping. And what the issue is today is our Lone Star Groundwater Conservation District Board wants to go back to pre-2015 pumping levels. And that's really the fight now that makes this story, it should come to the front.
Okay.
Anyway, go ahead.
Getting a little ahead of me. So they went ahead on basis of this and built a pipeline. And against, I was Chicken Little, I was out there, hey, but you're building this on an active fault. Look at my house. It's dropped another ½ inch a year just in the time we were talking, and to deaf ears. I gotta say, the guys building the pipeline are reasonable. I put a lot of hyperbole in that, but basically I made no ground headway. Till I brought up this.
When
This
you
is a
say
historical.
when
Go ahead.
you say they, are you talking about the SJRA or Terracon?
I'm talking about both, because Terracon did the original work. The same geologist that was working for Terracon is now consulting for the SGRA on going back and making sure that there is no fault activity.
By the way, Terracon did the geotechnical report for Perry Homes, the Woodridge Village development north of Kingwood that flooded 600 homes here. They clear cut that property and they didn't manage to get all the detention ponds in before we had two big rains back in 2019, one on May 7th and the other on September 19th during Imelda. The Terracon connection is significant because Terracon took soil samplings everywhere that let me put it this way, they did not take soil samplings where they intended to put detention ponds. And what they found is they started to dig the detention ponds is that they filled up with water as they were digging them. That's how high the water table was.
Ouch.
So the sampling technique of Terracon was suspect, to say the least. They did not they did not also do any soil samplings where there were wetlands on the property or stream beds that had crossed it. So
well, there's something to faulting and water. When they did remember I told you to plan my foundation, they did 20-foot borings on each side of the house. The one on the boring they did on the downside of the house filled with water with it before it was 8 inches deep.
wow.
I mean, the water table in my yard on this downward side is considerably lower than it is on the back side of the house where, the high side of the ridge.
Well, I think what happened in the case of Woodridge Village was that they were instructed to take soil samplings at certain locations, and they did, and they found no problems and called it a day.
Well, I think that's what Fugro was doing for the Woodlands when they ran it, when they Bob, what's his name, Bob Elder, I forget his last name, who is an expert at this stuff. That's how they discovered the Panther Branch, Jones, and they didn't know the Jones, but Panther Branch and Big Burnt Faults. Of course, through the Cockridge Crossing was by doing that kind of soil sample work for the Woodlands.
Well,
anyway,
it sounds like they had the integrity to report it.
Yes, they did, and it cost them. But anyway, so the location of the high school parking lot. This is a Google map. You can go to Google Earth, and you can dial back historical maps.
Right.
You ever done that?
Yep.
Okay, so this was in March of 2011, the year before they did their report that said there was no photographic or field survey evidence of a fault. This is the high school parking lot. There's a fault crack in 2011. 2 years before I was sitting in my house explaining to these guys, I thought that might be corrected to this fault. I mean, I'd seen it. They knew of it, but after by the time they were building the pipeline, I discovered this. In fact, it may have just come out that I discovered this trick of being able to go back and look at historical maps and apply that to current, measurements and stuff. And lo and behold, there it was screaming at me. This is the most obvious sign of damage to man-made structures by a fault in the entire Woodlands, probably in North Houston, because that just screams at obviously being a fault.
Before you move on, let me ask you another question about this one. So you're assuming that this fault goes from your house to the parking lot, but the damage in between just hasn't shown up yet.
Actually, it's harder to see. Yes, it was harder to see because it goes through a lot of residential areas.
Okay.
And they're claiming that there is no fault evidence there. I happen to know from talking to some of my neighbors that there is.
Well, let
They
me
just, but
finish the question. Let me finish the question.
sure.
Is it possible that, here, watch my hands
Okay.
on me. Is it possible that you've got one fault over here and another over here, and they're growing towards each other, but just haven't yet connected in the middle?
That's an argument that the geologist is implying, at least, if not actually using, that I happen to live on what's called an antithetic fault. Instead of being down for us toward the Gulf of Mexico, which is the way that the surface of the coast of South Texas goes. I mean, if you live between the Rio Grande and the Sabine River, your soil is moving toward the Gulf of Mexico ever so slowly. But he says that antithetic faults can stop and start, which is kind of what you're implying, at odd intervals. They're not seamless. You know, they're not even really related. And there is some growth fault evidence that you can have these plates that, as you say, meet in the middle sometimes.
Yeah.
But I don't know anything about faults. All I'm doing is look at the surface of the earth and say, I'm totally topographically oriented. So he may have had a point. I didn't believe it. I still don't believe it. And I'll show you why in just a second.
And
There are several different types of faults, you know.
Oh yeah, yeah.
Yeah, the last one you were talking about is called a strike-slipped fault, where you have ground that pushes up over another area. It's caused by pressure from behind, and it forces the other to decline.
Mm-hmm.
But that's just one type of fault.
Yeah, I don't necessarily buy that here because the faults are perpendicular to the fault line.
Yeah. So before you move on, let me mention another thing that occurred to me as you were going through those maps earlier on of the faults. You know, you mentioned the Conroe
fault system. Yep.
And there were faults all around it. That is typical of areas that have salt domes. And one of the reasons they're popular for petrochemical exploration is that as the salt is buoyant within the earth, and as it pops up,
as diaperism takes place,
right, there are cracks that form around the edges.
Yeah. As the salt dome diaperizes and goes through a layer of minerals, it just shatters like glass almost.
Exactly. And what happens is those pockets become collection areas for oil and gas.
And George Mitchell was known to spend all of his waking time down in the bottom of the Esperson building looking at swiggle charts of this area. See, he bought the woodlands because he could make money. He could break even on the surface and make his money on what's underground.
There you go.
He happened to be near the salt dome and the oil field that powered America through World War II. The Conroe Salt Dome was, well, don't get me started there, because I can do a whole other slide presentation on the Conroe Salt Dome, the Salt Dome fire, the soils, permeability of the soils. You know, when they were trying to define the source of the oil in Conroe, they would drill a test well, and that soil was so porous that the Christmas tree, the blowout preventer, would fall down the borehole. And when they finally struck oil, okay, and the Abercrombie one well, when you really found one that produced oil, it blew a hole 600 feet deep that filled with hydrocarbons, absorbing the Abercrombie well and another one near it, and burned so fiercely that you could see the fire down in Houston.
Wow.
Now, 2 technologies were developed to put out that fire, and it took them a year to do it. Humble immediately bought the fiery well because you didn't have to pump it. The hydrocarbons are flowing in that fiercely to keep it fuel. But if they could just find a way to extinguish the fire, man, what a godsend. This is Exxon now, but whose headquarters in this area. But in order to put out that fire, they developed 2 key pieces of technology. One was Eastman's whipstocking, horizontal drilling.
Yeah.
And the other one was GECO's portable drilling rig. You know, they took a pickup truck, instead of having a steam-driven engine do the, turn the bits, he just put it on the transmission of a pickup truck, and he could drive up to a site. He could do 10 wells in the time it used to take a steam drill to do 1.
Wow.
These technologies became extreme. Yeah, at the time they were doing those, early between 1929 and 1933, Mitchell was a graduate student or nearly completed his geophysical degree at Texas A&M University. You think he wasn't keenly aware of how rich that Congo oil field was? So,
well, yeah, oil depletion is also a major cause of subsidence. It's
Yep.
not just water pumping.
Yep. I wish I understood that better. Anyway, so let me finish here real quick. The high school, but this is a 2011 photograph that very clearly shows what I predicted they would find before they ever started laying that pipe. And before this reason, but because of this photograph, they went ahead and agreed to do a survey just to show me, or not me, to show the community that there is no active fault north of Research Forest. This thing across the parking lot, that didn't go all the way to my house. So you see the line between my house and the parking lot, that big white one?
Yeah.
The red one is where they put the survey line. Okay, the street that on the lower right side, that's the entrance to the Woodlands High School.
Yeah.
The pipe goes just southeast of those 2 cars. Right, if you go right along the shoulder of that road, that's where that 42-inch pipeline is. This is one of the busiest intersections in the Woodlands twice a day with kids. And underneath that intersection is a 42-inch pipeline. Now go back in your mind and think of that 28-inch one on the UCLA campus. So this was generous by necessity, I think. But so here's what the survey, here's the kind of the layout of the survey. There were 19 monuments. These are 3-foot rods, metal rods with a cap on them that they would bury. Okay, tried to bury them about the same level, but that didn't really make any difference. Then they would, so it goes from MBM 1 farthest to the west, all the way across Cat's Cradle to MBM 18 to the east. Now I've marked the ones that are east of my projected fault line in black, and the ones west of it in red. And again, going back, because this is a downthrown fault to the west, my prediction back in 2013, long before they even built this survey line, was that they were going to find lower measures west of the pipeline and higher measures east. Now, I had no idea, Bob, at this point in time. See, my thinking up to this point in time was that fault is the effect of diaperism, the Congo salt dome rising through heavy mineral layers. And I probably had one of those shards of that broken mineral layer running underneath my house and lifting up.
Wow.
But it turns out the story gets a little more interesting. So halfway into the study, now what's happening is they're coming out every 6 months in March and in September and remeasuring the elevation of each of those monuments, okay? So what you're seeing in these numbers, and you're gonna have a hard time seeing them because of the size of them, is they're measuring each monument to the nearest hundredth of a foot, but the elevations they're reporting are in the 150-foot range. So it's like they have a 150-foot ruler and they're trying to look for changes as small as a hundredth of a foot. So when you present the data at the granularity of like this first point up here in the leftmost top row column is 142.59 feet. How could you possibly, and the only significant number here is the fifth number. It's the 0.0x number. So how can you look at this and make any sense out of a pattern of elevation changes visually? So at the fifth remeasure, they're saying they don't see anything in the data. And I presented, this is a graph I had presented to them at that time. The red numbers were all negative numbers. The black numbers were all non-negative numbers. I had set aside green for any elevations, but there weren't any. But you can see that except for that bottom row, everything south of MBM 13, which is that the last black dot before you get to the predicted fault line, those are all 0.00 feet. In other words, after 2.5 years, those things haven't dropped a hundredth of a foot, any of them. And every point west of that fault line has dropped at least a hundredth of a foot, if not more. So now, they all started at 0.00 by definition, because that was our baseline measure.
Where is 20? Oh, I see it up there. Okay.
20's up there. Yeah, it's
the top.
Just west of Cat's Cradle. I had them, you know, they very begrudgingly put that in after the thing was designed. This was all complete because I wanted one that was perpendicular to the actual fault line, 50 feet like my house was.
Yeah.
And you can understand why, because if not, it's kind of like you're measuring over a ridge instead of perpendicular to the ridge. You're trying to see how much it's trying to lift. Okay. Are you getting tired of this now? I can pick it up later if you want.
No, this is good. Go ahead.
Okay, we'll keep going.
Hey,
So
hang on. Let me get a something to drink here.
Okay.
I'll be right back.
Bring me some. Bob wanted to get something to drink.
That's what I went to do too. More Diet Coke.
Well, I was hoping it wasn't to kill the pain. Is this going? Are we going too deep here?
Oh no, I think when I heard that he's also got a fault line, this is of great interest. That's incredible.
Okay. Okay, I'm back. So we're halfway. Even faced with this data, at the halfway point, I couldn't convince them that there was a fault there, active fault there. Here's the review I got. And this is, you can go out their site and you can actually see this, the paper on the left is the report, and it's still out there. Here are the comments he's making about my data, my analysis of his data. Saying, as suggested in my October 11th, 2016 report on the third remeasure of the benchmarks, a fault movement event will be demonstrated when most or all of the benchmarks on one side of the fault show a consistent up or down sense of movement compared to those on the opposite side of the fault. I think I met that in spades. There's not one exception, okay? It's exactly as I predicted in 2013, and this was in 2017. I'm sorry.
So these 0.1 and 0.2 movements are over the space of 18 months?
No, they would be over the space of 24 and 12. No, I'm sorry. 12, 12, and 6. So 30 months.
30 months, okay.
Yeah, 2.5 years. Okay, so I met the pattern criteria. But now he throws in a whole new criteria. I should have added that the rate of differential movement between the upthrown and downthrown sides of the fault should exceed approximately 0.15 feet per year, which translates, Bob, to about 45.72 millimeters or 4.7 centimeters per year. That's a ridiculous rate of change to expect in the surface of the earth. See, I'm only seeing a ½ inch. I'm seeing 2 centimeters. He's saying if it's not 4 centimeters, it's not important. It's not real. You can imagine how I felt.
Yeah. Okay.
So here, if you go out to their website now, which I've got on the bottom, and you look at the results of the W2A Geological Monitoring Survey, you'll recognize the layout on top of the paper. You'll see the monuments down here. This is the report they're giving the public. This is the data that they've gotten from Land Tech. You can't visually see a pattern in that. You can't expect anybody to see a pattern in that. This is so overwhelmingly noise that you couldn't possibly detect a signal that's happening in the 5th significant digit.
Yeah, that's
so
presentation technique.
So what I've got here is I have taken their data and I've converted it all to change scores. In other words, I take the initial measure and then I report at each individual cell the difference between that cell and the original measurement at that monument. Don't do anything to it. I just lay it all out in a line. And you can see from the top of that, I expected a drop. Negative numbers were in red. No change in elevation was in black, and a rise was originally going to be in green. There's no green here. So this tells me, most importantly, that the faults we have are not probably related to diaperism at the Conroe Salt Dome.
Because it's not rising.
Exactly. It's even where at the up, what they call the upthrown side, it's not up. It's staying the same. And what's happening is the downthrown side is dropping.
Mm-hmm.
Is that clear?
Yeah.
That pattern, it doesn't, you could almost be blind and still just take a look at the color pattern and say, hey, there's a pattern here. This is not random. You're not seeing a kind of a color mix that's uniform across time and across monuments, which is what their hypothesis says. Now he's got the null hypothesis. I'm trying to prove my own theoretical hypothesis.
How much money have you spent raising your house?
I have a lifetime warranty on my foundation, which they don't offer anymore in the Woodlands because several of us have gone back and had like multiple relevels.
I see.
And that's expensive. I only had to pay for it once. And it was about 50 grand.
Wow.
This is painful. So here, if you add the projection of my fault line, Bob, and that gray line, it becomes even more clear. What I'm using kind of a Bayesian approach to these numbers, kind of like a Moneyball approach.
Yeah.
Where I'm actually trying to predict the probability of the next cell. What's the probability that I'm going to get a drop if I go to the next cell? So the probability of getting a 0 number west of the fault, another 0 number west of the fault, is less than 5%. If you take all the data into consideration, even the early data, if you take just the second half, it's 0. There's no chance of getting a 0 elevation change west of the fault line. However, east of the fault line, everything basically within rounding error is staying the same. See, the difference between a 0.01 and a 0.00 could be as little as 0 0.001, a thousandth. Because if I have a 0.004 and you add one more to it, it goes from 0 to 0.1, 0 to 0.1. So this is all within rounding error east of the fault. Now, I'll show you some interesting phenomena here. Let's go back to my house. Remember now, my house was built in 92, and until 2013, I had until I brought all of those guys into my house in August 2013, I had shown a half-inch of drop a year. Well, let's go back and add today to where my fault is today. If you put in 2020, my house since 2013, my house has only dropped another 1.3 inches. Now, the pipeline, GRP pipeline, wasn't opened until 2014. Okay, so that 2013 and 2014 would add another inch to that cumulative drop. So really, it's only dropped between 10.9 and 11 point. It's dropped 0.3 of an inch in the last 5 years. So until they opened up the GRP pipeline, my house was dropping a half inch a year on average every year between 1992 and 2014, or 2013, actually, I have real measures on it. So that's 21 years. And then all of a sudden, they open the GRP pipeline, and over the next 5 years, it drops just a fraction of that, 0.3 of an inch, instead of 0.5 inches per year. That's 0.3 inches over 5 years.
So you go to surface water, the subsidence stops.
Could it be? I mean, 21 straight years, you know, I wake up every year and I see the same thing. I wake up every year. 21 years, all of a sudden, bang, the world's different to me.
Yeah, and now they want to make it start again.
Right.
You're getting ahead of me. So I'm armed with this, but in July 24th of 2019, do you know Mike Turco? Have you ever met Mike Turco? He's with the Harris-Galveston Subsidence District. He came to a Woodlands Township meeting with this data. He showed, I've added to it pieces, but he showed from 2001 all the way to 2015, a linear drop of what? 2.0 centimeters per year. That's about a half inch.
Yep.
After they opened up the GRP pipeline, you can see where that became operational and where the study began. In other words, they didn't even begin to do this study for the fall until they opened up the GRP pipeline. And that geologist is trying to tell me that my data is my observations are insignificant because there's not a reasonable drop in the size of the fault. You follow me? It's a little complex, a little contorted. But the GRP pipeline basically shut down almost all faulting activity. And it was hard for me at this point to prove, it was harder for me to prove that there's actually fault activity going on. Now, at this point, hadn't had time to really absorb what the GRP pipeline was doing to my data set. But look at that.
Yeah.
It's a one-to-one relationship between subsidence overall in Cochrane's Crossing and what's happening to the downside of my house.
And
So
water
is this vertical line here, the year, did the pipeline go in?
Pipeline has been going in just to the left of that black line. See, it says no alternative water required. The subsidence rate was 2 centimeters a year. Then you got that vertical red line going to a black arrow.
Okay.
On the other side of that, alternate water is utilized. That's the GRP pipeline was opened up.
Okay.
There is no question in my mind. But the Lone Star groundwater people think there's no such thing as faulty. And depending on how you define it, maybe that's true. But I'm just seeing different levels of, differential elevation levels growing.
Yeah.
So,
okay.
So let's go on to the next one if we could. I did something kind of different. I had in 2014 when it looked like I wasn't going to get an even shot at proving my point. I worked with the University of Houston, and we established a continuously operating reference station on the high side of the Panther Branch Fault on one of the buildings at the Woodlands High School. So I could actually set a GPS antenna, precision GPS antenna, right next to the upside of the fault that I lived on, below Research Forest at the high school there. And that GPS system has been collecting latitude, longitude, and elevation to the millimeter level since the late 2014, storing it all in a huge big database at the University of Nevada. And lo and behold, you can access it on the internet. Look at what's happening in this right side frame to the ground. What this is, Bob, is this is like that 145 foot mark, or that elevation, 145 foot point something, is with reference to a elevation measure taken in the Lake Conroe Dam to a bolt that sits on that holds the light post at the street light post there right in front of the high school. That's their 0 point. That's their reference point. Then all of those other monuments are measured in relation with a traditional survey methodology to get an elevation for them. And they do that every 6 months. They do it in March, and they do it in September. So what this data basically reflects is, I think, it's yet to be actually physically proved, but it's obviously is the case. It reflects what's happening to the top of that bolt. It's rising and sinking a little bit seasonally every year, but over the long haul, it's dropping down a little bit. It's probably lost, maybe 1.5 centimeters over those 5 years. 1.5 centimeters, and he wants to see 0.15 inches per year. Okay, so this data also shows you that basically this GPS system is as accurate in an elevation at that point in time and space as you could possibly get. There's only God knows it better than this data. This is as good as it gets. This is how they measure tectonic movement. This is how they measure the effect of subtle changes in your surface with this type of long-term GPS system. This is how they knew how much earth was removed from Mount St. Helens when it blew. We go out there with GPS data, and we take these kind of measurements over a long period of time. But the other thing I want to show you is that the seasonality, the elevations, the one on the bottom, the frame on the bottom, it says up millimeters, and it goes from +20 to -20 to -40. Notice how in 2015, in the first quarter, we're at a peak. In March, the elevation is the highest. In September, it's the lowest. And remember, they're taking their measurements every March and September. So let's go back up and let's look at our data. And over here, you'll see the monuments. Can you read the data points here a little bit? Can you see the numbers in those cells?
Yeah.
Okay, so in the first one, they're all black, but that basically that's not as important. That's the baseline. You might, for our purposes, you just consider that 0.00. 915 is where we take the first dependent variable. And we see that the bottom 3 rows, MBM 16, 17, and 18, appear to have dropped just a tiny fraction. I mean, it's not really It's not important. It's just could be within rounding error. But the fact that 3 of them have dropped, then the next March of 2016, they're all black. But then in September of 2016, they're all red. A couple of them are red again.
Yeah.
2017, they're all black.
Yeah.
But in September 27, they're all black. They didn't turn red. Then in September, and then March of 2018, they're all black again. And in September 2018, the bottom 2 are red again. And they are red again in September 2019. What happened in 2017 to keep those from turning red, I wonder? Hurricane Harvey. August of 2017.
Yeah.
It's not important, but it does suggest to me strongly that the water levels have something to do with elevation in this area.
Well, Harvey was reputedly depressing. There was so much water that fell on top of the earth. It reputedly was compressing the earth and pushing it down. They noticed a lot of subsidence in the Houston area because of that.
Well, okay, we can go back then. We can test that hypothesis. We can go back in time and we can look at, let's see, 2017. You should see an irregular pattern of elevation if that's the case. And you might, because if you look down there at 2017, there's a little dot going through there. There does appear to be either a time correction or a little difference in the peak and trough of 2017 compared to 2016 and 2018. I don't know if that's significant, but keep that in mind.
Yeah. Okay.
So what I'm arguing here is I can control for other extraneous factors in subsidence with this reference station that's sitting on the high school. As far as the measurements themselves go, whether there's a pattern, I've done a frequency table to look at the distribution of scores before in the first half of this study and the second half. And if you look at, there is no overlap in the second half between the scores in the first half of the study for West and the second half. They completely diverge. The East faults look almost exactly the same. You could do a non-parametric analysis of this data and come out with a significant score, but I'm not good at non-parametric stats, and it's a worthless exercise for me. But there is just no question that the Western fault has no overlap with what's happening on the East.
Is all this data on the right-hand side of the slide with the blue and red lines? Is that data that you graphed, or is this turquoise graph?
I'll show you. No, that's not no. That's graphed by the Houston Net, University of Houston's core station on top of the high school is sending all that data out to a big database at the University of Nevada, which is where they store all the fault data for our surface data from all of the world, basically. And they can do automatic presentations of this data in many different formats with different kinds of time corrections to the data. This data is going to go on a lot of filtering to get it this organized. So one point that I really want to make is I'm concerned about the timing on all this, because every day that goes by, we are continually erasing evidence of faults. Here's you can see on the left side of this, Scarp Locations 11 and 12. This is where my fault crosses College Park Drive or Highway 242 to the north. In February 16, 2018, you can see the pictures of the trucks where they're erasing the location, the Scarp Location 16, just above my house. That's gone now. You can't walk out there and see it. I know where it is. I can monument it, but when I'm gone, that data might be gone. So let me take you to real quickly. I'm not going to bother you with too much more of this, but I want you to see the real posses we've got going on here, real possibilities for the future. And you could apply this to Kingwood as well. Look what the data, if you want to see where the data from any of these core stations, in fact, you might even find one in Kingwood, you can go to this bottom location, HTTP, the geodesy.University of Nevada at Reno.edu site. That's where all the National Geographic Laboratory station pages are all stored. You can find them all on a map. When you go to this location, you're going to get a big map of the United States. You're going to see little boxes. And you just go to the geographic location that you want to go to. And like, this is the high school, okay? This is the antenna of the high school. This is where it is. Panther Branch Fault, my house is Scarp Location 16. I have one of these reference stations, not only at the high school here on the Panther Branch Fault, but I've got another one that I say I've got, my wife has made sure I don't do it anymore. We have a reference station at the high school, a reference station at Powell Elementary School on the Jones Fault, and a reference station at Gladys Elementary on the important master fault here, the Big Bark Fault. Which means we could do that kind of analysis very quickly on any of these faults in the future if we want to. So here's the WHCR is the one on PWES is Powell, Gladys. The this one at the top is where the University of Texas A&M's, Texas A&M's research station for Jones Forest. That's that big wooded area down below it. They have a research station up there, and that's another core station. Now, if you want to see the results, you can navigate to the wood, go to that map I showed you, go to that little square, which is going to be WHCR. You click on that square and you get this little box to the right. And then actually you're getting a little bit different version of it. Next to this box is going to be a whole different way, a lot of different kind of corrections you can apply to the data. And what's happening here, Bob, is these stations all receiving timing signals from satellites, right?
Yeah.
And the timing signals can kind of arrive at a little bit different intervals. They're slowed, sped up by different things. What happens is each of these signals, each of these stations triangulates on the nearest other couple, and they can time correct. And so this whole process is correcting and getting rid of extraneous points that obviously aren't relevant, and then averaging over a lot of data, long periods of time. That's why you get the kind of precision we're looking at here.
Okay.
Okay. So I have a range. This is the high school, Woodlands High School. This is the Jones Forest, Powell Elementary, and the Lake Woodlands. Let me see if I can't, just for the fun of it. Sorry, I'm trying to launch this just so I can take you through a exercise of getting.
Command C.
Did I get that? I don't know. If you go to it, you'll get a map. I'm sorry. This other section up here gives you a good definition of what the global positioning, what these core stations really are, how many of them there are around the world, how they work, what the time corrections and all that stuff is.
Okay.
So if I can wrap up kind of this long, this odyssey that I've taken you on, what I think I've shown you is that there is very convincing evidence that the fault that I live on is an active fault that does cross the high school. And for that reason, it ought to be taken seriously. I've also shown you that even with the opening of the GRP pipeline, it's corrected the real challenges of subsidence in our area, as long as groundwater pumping doesn't return to pre-GRP levels. Right now, there is an assault going on. People that don't want to pay the high rates that surface water costs, they want to basically got a free range, laissez-faire on groundwater pumping unless it drops to a level of, like, I've heard numbers like, we could tolerate a foot of subsidence without any problem. What I tried to point out to some of those people is, I found at my house that an inch of subsidence on the surface translates to an inch in the drop of my house. It's a one-to-one relationship before and after the GRP pipeline. If you reverse the effects of the GRP, what are you going to be doing to my house? Could you imagine what that foot threshold would do to my house? Instead of stepping up a foot to get onto my house, I'd have to step up 2 feet. Now my whole foundation would be so high, you'd be able to, from the front yard, you'd be able to look underneath my foundation and see the tops of the piers that hold it up.
That kind of subsidence can't be tolerated. There is no good amount of it.
Well, worse yet though, right now, San Jacinto River Authority is a little less concerned about my data, because they realize that with their GRP pipeline, opening up, those changes are so small they can tolerate those. Statutes of limitations will protect them. I say that lightly. No, they understand that we could tolerate these kind of changes, because long before the pipeline would break, we would see some tensions, but if we're watching for them. But without any kind of measurement, without any kind of tool to be able to measure the effect of water removal on changes in the faults, we won't know. And right now, there are factions that want to shut down. Well, they don't want to shut down the pipeline because they don't want to pay for the increased cost of the increased demand on pumping water, because that's all surface water coming out of Lake Conroe. It allows them to have more water to pump down below. But if we were to allow a foot of subsidence, that's enough to break that pipeline. And you would have a situation very much like you saw on the UCLA campus. More importantly, we have presented the Woodlands with a unique opportunity, and this is where I could use you. We have presented a unique opportunity for the powers in this area to use Cochran's Crossing, one of the villages where all the faults go through, where we know we've got 20 years worth of subsidence data from Mike Turco. That's the Harris Galveston Subsidence District. His data, incidentally, was recorded right next to a high school in my house. It's within 2 blocks of where I live and the high school. So right in that location, we've got a wonderful measure that's been verified by him. It's been verified by my house. It's been verified basically by almost all of the homeowners I know that are on where houses were built on faults in the Woodlands. They've had the same experience I have. And it's been verified by NASA and SMU, who did a study of subsidence in this history using INSAR recently. It's about a ½ inch a year until they opened up the GRP pipeline. There's almost no question that's been an effective tool. Now, I could use your help, not use you, use your help in just making people aware of what we now know from scientific observation. It's not easy for me to do because SJRA still has on their website the original professional geologist's opinion that there's no fault, no evidence of an active fault here. I had cheated because I really didn't go through a complete description of what what his reasoning was, but it's specious. And I can take that to you sometime if you're interested. But I need for people not to see the cost involved in this. I need them to appreciate what the ultimate cost is if we were to let that pipeline be destroyed. That'd be the loss of 30 million gallons of water almost instantly. It would require an immense increase in the amount of water being pumped to keep now supply all the houses in the woodland that are currently being supplied by surface water. It would devastate at least a dozen houses that were involved in the lawsuit against the woodlands because their houses were built on faults. It would completely disrupt neighborhoods. You know, Stewart's home would be under 4 or 5 feet of water. And it would be a real risk. Could you imagine having a kid in a car underneath, sitting at the light, waiting to go home, and having a 40-inch pipeline blow underneath them?
Double the size of the UCLA pipeline.
Exactly.
Mm-hmm.
What do you think?
Yeah.
Do I sound like I'm one of those 1960 guys that is still high? Never got over the brown tabs.
Another child of the 60s. Hey, Mike, first of all, let me say this is amazing. You have collected an immense amount of data and done a great job analyzing it.
Well, that's kind of you to say. Thank you.
And I have, you've convinced me that there's a real problem there.
Opportunity.
Yeah, having said that, let me also say this. It took about an hour and a half to get through the presentation with, you know, a few questions, some interruptions in there, but I think, you know, if you want to communicate the danger of this, we've got to find a way to simplify it. And as you were going through it, some thoughts immediately occurred to me. I mean, you know, there are different levels of explanation that you can get into here. It's sort of like, you know, layers of an onion.
Yep.
You know, how deep do you want to go? You took us all the way to the center.
Sure.
I skied it and surfed it.
But if you, let me just offer a couple observations.
Please.
Okay. As you were getting into, after you showed me the pictures of your house, my emotional reaction was, holy shit. You know, you had me sold right there. And then we kind of shifted directions into the discussion of the high school and the water line and the threat that it, you know, has and all of that stuff. And as we got into the data that supported that, there were so many qualifications and conversion factors and things like that that you put on it that it was hard to
follow.
Yeah, it kind of got hard to follow. Let me give you an example. You know, just a real key one in terms of conversion factors is you're talking metric and imperial systems when you're talking about hundredths of a foot. And in my head, I'm trying to think, Jesus, what's 100th of a foot? You know, what does that convert to in inches? And then I started flashing on, why is this so much less than the subsidence he showed at his house? And you later explained that, but we took that, you know, huge long loop that may not be necessary to make the point about the danger.
Listen, I used to be a college professor, and my wife and I both were, and I understand exactly what you're saying. You know, the problem is to get. I gotta take you a little bit through the mind of the people I'm trying to convince.
Okay, I get that.
Yeah. Okay.
Uh, by the way, I was a college professor too.
Good.
Um, at Northwestern.
Yeah. Okay. Well, I was at Wake Forest.
Pardon?
We taught at Wake Forest.
Okay, great school too. At any rate, the real issue I have from a communication point of view, okay, trying to be helpful now, and is how do we streamline this thing so that the average person can open up the presentation, scroll through it, and understand what you have without all of the verbal explanation that you offered in the last 90 minutes.
Okay, I'm with you. I'm exactly with you. I understand that that's where it needs to go now. The problem is I had to convince the people that have a lot of interest, you know, in invested in not seeing faults. This has been the history of the woodlands for as long as I've lived here. Nobody really wants to see a fault. When they see one, they're not gonna. They can give you all kind of other things it could be. And I'm happy to eliminate those things systematically. My punch line here is I open up with, if I'm talking to just a totally lay group and I can make some assumptions about science, I would like to just open up with the part of that YouTube video on the high school where they talk in ominous terms about, you know, a 28-inch pipeline and 20 million gallons of water, how long it took them to turn off that pipeline, and it flooded Pauley Pavilion and all the athletic facilities and parking lots were into millions of dollars, tens of millions of dollars worth of damage. I would like to go from that right to saying that pipeline is underneath the high school. This fault crosses the pipeline, a 42-inch pipeline, right underneath the high school. Now, I can't make that conceptual leap as much because I've been involved in the hard data. But somebody like you coming in, if I can convince you that the science is real, I'm hoping you could just let's go from one point to the next logical point. Not only is the fault underneath the high school, but it's probably active. And get this, the activity of that fault is probably just like the surface of the woodlands. And let's look at what happens to the surface of the woodlands over the last 20 years. Right before we opened the GRP pipeline, bang, it went from half-inch a year to it just stopped.
Let me ask you this question.
Yeah.
So you showed the crack in the parking lot from the satellite photo. How do they explain that?
It's an antithetic fault, and antithetic faults are unusual faults. They kind of start and stop. It's because it's not continuous with my house. It's probably unrelated.
But still, the pipeline crosses it. How do they explain it?
Well, that's their problem. I think that's just, if you saw from my core station, the continuity of those lines, there's nothing starting and stopping about any of that data. Not only it's longitude and latitude shifts, its elevation is very consistent with seasonal data. There's nothing sporadic about that. It doesn't start and stop. It runs very, very linearly and very consistently. There's nothing start and stop about the subsidence in this area. Look at Mike Turco's data. Look at my house. It's all a half-inch a year until you turn the GRP pipeline on. Now, you can simplify it because you're not up to your eyeballs in talking to these technical people.
Yeah.
You can say, I was just told this by this guy down up in the woodlands who had some pretty convincing, I just, like Donald Trump and Fauci. Except I hope you got more credibility than him.
So let me ask you this question. Here's another issue. This is going to sound kind of crude, but
No,
it'll communicate the issue. Will it move people's give a shit meter? And here's what I mean by that. So like, it's affected you because this fault cuts right through your house, but you have people on either side whose houses are sinking with the subsidence or, staying level on the other side of the fault. And so because their foundations aren't, you don't have a split level house with them like you did, they may not care as much. So how do we communicate to those people who live away from the fault that this is important to them?
I can provide you a paper. I can provide you a paper from the lawyers who are recruiting people to join a lawsuit against the Woodlands Land Development Company. What this lawyers did is they hired a geology firm, geotechnical firm, to go out and follow these fault lines with a little handheld GPS system, and then take street addresses of all the houses that they thought were next to or across the fault, and publish that. Put it up on the internet one day, and they took it down the next because they realized what they had done in terms of liability. They're proclaiming people living on a fault that don't know they're living on a fault, and you can't prove they're living on a fault publicly. So they snatched that sucker down. But I have that paper. I have that list. And I can tell you, you could take a look at that list, and without identifying who those houses are, say people have looked at, and there are probably, let's go with this number. There were probably 12 to 24 houses that were part of the lawsuit against the Woodlands Land Development Company that Gordy Bunch ran. Gordy Bunch actually funded the research for it. These other guys got into the contingency lawsuit where they just kind of wrote on Gordy's lawyer, who was really good, and tried to sue the Woodlands for having sold them property on an active fault, and the Woodlands knew it was active. It turns out that I've got all the documents on that, but I knew they knew the Woodlands was active because they had a guy named Pappas, an engineer for Mitchell, who wrote an internal note saying that we're probably crossing faults here. But they didn't find Gordy's, they turned down the plaintiff's case, not because there was a fault, not a fault, but they turned it down because Texas statutes of repose only limited the liability of the development company 10 years after they did the original design work.
Yeah, Jesus.
So here's another angle, Bob. If San Jacinto River Authority just, we've slowed down the fault. If we just wipe our hands in 5 more years, they're already 5 years into it. I've been measuring this stuff for 5 years. In 5 more years, they just can wipe their hands and say, look, we told you that you're going to break this pipeline. You broke the pipeline, you break it, you own it. They're free because there's no way that residents of the Woodlands can go back on them and ask them to assume some liability for this. It's going to be up to the residents.
Yeah. Well, getting back to the question about, do you live on the line or off the line? And is there a difference among those people in terms of how much they care?
People that sue the Woodlands. We've all, Gordy Bunch, who started this thing, he has a 2-story house with a pool. He came out one morning and his pool was broken in half. And his house is broken in half.
I get that. I used to live in coal country in southwestern Pennsylvania.
Okay.
Near the West Virginia line, and saw a lot of split family homes there. Um, it was just heartbreaking. I mean, you'd see, roof lines offset by 2 or 3 feet.
Yeah.
Where they had, tunneled under your house.
Yep.
And things collapsed.
Yep.
This is real. But again, my question is, does interest diminish the farther you get from the fault line? And
yeah, it does. It will. But see, there's so many people right now who don't know, because they've obscured the fact that we live in a fault lattice area.
Let me finish the question, Mike.
Yeah, please. I'm sorry.
If that hypothesis is true, how can you present this argument so that the people away from the pipeline are interested? That's the big question.
Here's my thing. Everybody pays for water. And we built the surface water treatment plant, $500 million. We sold the bonds, and it went live in 2015. Mark shows and Turco shows, everyone sees that subsidence ceased almost completely, right?
Yeah.
And now what's happening is they're asking us to go back to pre-GRP going live withdrawal rates from our aquifers. And when you do that, you've got to have bigger pumps to pull the wells, to pull the water out of the ground. And there's a paper written by Aaron Schindewolf of SJRA estimating that it would cost us $60 million to retool our wells to drill deeper. So I try to convey whenever I get the opportunity that this is going to cost anyone who's drinking SJRA water increased water rates, because SJRA only gets their money from water users. They're not a taxing, and so there go our water rates, was the point I made to the township board.
Yeah.
So that affects everyone. I also think that when you can show that subsidence changes the Earth's contours and you are going to have flooding, when I called my auto insurance and it went up because I believe I've seen evidence of all the cars just simply parallel parked on the street, and we have a big rain event. You've got water going into the tailpipe and even into the inside the body of the car, and you've got ruined cars, and car insurance covers a flood where you have to get special insurance for your house. So focus up, folks. Your car insurance is going up in 77381, which is our zip, because of that. So, it's going to cost people more on their water. And what frustrates me as the accountant in the room is, we sold these bonds and they need to be paid off. And we're looking at the SJRA GRP division is now going into their debt service reserve fund as of 2 months ago to pay for this, because the Woodlands Water Association agency refused to pay for the lawsuits that have all come. So there's a GRP lawsuits that GRP is involved with is Splendora, Conroe, and Magnolia have all short paid the SJRA now for 5 years. And because of that short pay, that's why the GRP group is in financial trouble. And so the lawsuit, they keep losing it. They're in appeals now. And the whole situation, all people, Simon, Cicada of Quadvest, and the 3 cities I mentioned, are all coming at the SJRA to try to break up the GRP and get out of it and let the Woodlands, I guess, is their thought, pay for all of it. That's not going to work out. We had an agreement. They signed it. They said that they would pay the surface water conversion fees, and they've now reneged on it. And it's going to cost us. I mean, every single Woodlands resident should be out of control, honked off at this. But when the 2018 vote came and we were to vote for the LSGCD board, People didn't understand the issue. The news didn't get out. I did notice on election day there was a little change in the numbers to vote for the other candidates than the slate that won. But the start of this is this LSGCD board that is going to allow pumping to go back to pre-GRP levels. And it's, I use the word ruinous at the township meeting. This is not good for one single Woodlands resident.
Well, in my case, again, I think hopefully I've shown you, Bob, and you walked away with the idea that there is a 1-to-1 ratio of surface subsidence and damage to my property.
Well,
Half
absolutely.
inch of surface subsidence does a half inch of damage to my property.
Yeah, I got that loud and clear.
Okay, if they set their threshold for starting to throttle back pumping at 1 foot, additional foot of subsidence,
Yeah.
what does that do to my property? I didn't join the lawsuits. 24 families did. Each of their houses, they estimate, was worth about $500,000. That's $12 million right there in damage. If the groundwater group knowingly destroys my house, how are they not at some point liable?
Right.
Yeah, I mean, it's like the coal companies in Pennsylvania. You know, they own the legislature and they write the rules, and you can, you know, try and sue them, but they always point to the subsurface rights. And
Yeah, but in this case, we may have a wealthy uncle. We were developed by the Hughes Corporation, and the Hughes Corporation still has a vested interest in what happens. And it turns out they own almost all the mineral rights underneath the woodlands.
really,
Yes, Mitchell separated the surface rights from the mineral rights when he sold off the property. So I don't own any of the mineral rights, but I do own the surface rights now to my property. And yeah, so they are, and they're a political force. They're a big developer, obviously. So
are they with you or against you?
I gotta believe they're not for free pumping. Well, they're kind of complicated because, see, they're going to be competing with the water people because there's really no difference in terms of subsidence from water and oil. And my belief is that you know, when they sell their last surface lot, they stay on all the mineral rights, and we're sitting on a fault system that they've known for 20 years. Is here next to the greatest. One of the greatest oil discoveries in the United States. So.
Well, we've got a lot of the same problems here in Kingwood. We're not that far from you.
Yeah.
I mentioned the fault line that I live on. We're right next to Lake Houston, and it's interesting that people below that fault line all flooded during Harvey. Every single one of them. Hundreds and hundreds and hundreds of homes. There were multiple causes for that, but there's no doubt that you know, there is subsidence occurring. I told you what happened to my house.
Yeah.
I haven't paid quite as much as you, but I've had to have it leveled twice, and each time.
Did you do it by tunneling or by having them just bore through the foundation and put pilings in that way, or is it on piling?
Well, they tunneled underneath, and then they put the pilings in from the tunnels.
Who did it? You know?
Pardon?
Who did the work?
A company called Knight Engineering, KNIGHT.
Okay.
I know the principal. He's a good friend of mine. He could probably, you know, supply us with some pretty good data for all the homes in this area too, and we might be able to combine them and put together presentation that covers both the woodlands and Kingwood. The interesting thing about Kingwood is that, believe it or not, even though we're right next to Lake Houston, we are still on surface water or groundwater. For the purposes of the Harris-Galveston Subsidence District, we are on surface water because they average everything within the whole district.
Yeah.
And we meet the averaging requirement as a whole, but this particular area is still on groundwater, and I can tap into the USGS subsidence monitors for the area and see how we have subsided over time. It's not as great as you have. We're not talking, 6 or 9 inches. It's probably
that's over 20 years, 20 plus years.
Yeah.
Well, the subsidence map was included in Ron Kelling's presentation that I sent you. And the reason I sent it was I saw on that border of Kingwood, or I should say Harris County and Montgomery County, you've got pretty good subsidence going on in your area.
Absolutely. And
well, here's another question, Bob. What I think we have taken in total, and I'm trying to convince the Lone Star of this, Lone Star Water District, we have an opportunity to really understand how local and how regional some of this water pumping effects are. For example, it may be that we were pumping a lot more water in Houston area until the GRP pipeline opened up. It stopped real quick, and what they're pumping way north up near Magnolia doesn't make any difference to us. We won't know that until we actually have instrumentation that tells us what those relationships are like. Right now, as I understand it from the people at Lone Star, they're pretty blind. They're making decisions based on intuition rather than instrumentation. And that's no way to fly a plane.
Right, that's the problem. And there are other areas around us, extending even over into Liberty County. This Simon Sequeira that we talked about, is the more I learn about him and his company, the more disturbed I get. I continue to talk to activists over there in what they call the colonies. It's a development called Colony Ridge, and it's broken up into several subdivisions, much like the Woodlands or Kingwood are. If you look at it on a map, it'll look like 10,000 trailer homes parked next to each other, because that's basically what it is. It's accounted for all the population growth in Liberty County since the last census. It's amazing. It's about, right now it's 10,000 acres, and it's about to expand to 14. They're just pumping groundwater like crazy over there, and they're flooding. And they're also, the systems, who knows why, perhaps because of, subsidence here, much like you're talking about, the sewer lines keep breaking. And they're dumping raw sewage into the East Fork of the San Jacinto, which winds up in Lake Houston, which is the drinking water for 2 million people. It is crazy over there.
Kind of discouraging, isn't it?
Yeah, it's.
Well, let me, we've talked about all the downers here. Let me give you potential upper. You could imagine living for 28 years on an active fault. My house isn't worth squat on the tax rolls of Montgomery County Appraisal District because I live on an active fault. It I pay less than a quarter what my neighbors pay for comparable houses. And all of a sudden, out of the blue, a discovery of my own making. That is, this thing can be turned off. This fault can be stopped. When does that happen in life?
Yeah.
When do you go from living on an active fault to it's no longer faulting?
Yeah.
It's not my fault.
Well, what we need to do, let me make a proposal here to you.
Sure.
Why don't we work together, all three of us, to make a new iteration of this presentation that is dumbed down a little bit for the average person on the street. And perhaps instead of making this big loop into the pipeline crossing of the fault by the high school, we make an alternative loop that goes out and picks up the water rates and stuff like that.
Things that matter to people.
Pardon?
Things that matter to people.
Yeah. People who live away from the fault line. You can say that we went to surface water to reduce subsidence, and when we did, it stopped, basically. And the problems that we saw before the transition have also stopped. Now that we're going back to groundwater, those same problems could start again.
And they're going to stop in surprising places because we've eliminated everything we knew about those fault lines.
Right. And that could cause dangers like the pipeline rupture, like this, that, and the other thing. But we don't need to go into quite as much detail on, all the qualifications in the data. And just, having shown your house and the steps, we can then go back and say, imagine if the same thing happened to the pipeline. Boom. That's, I think, all you need to say at that point.
Well, just start playing the movie.
Yeah.
The pipeline break.
Yeah.
You feel like it was just walk away.
And then talk about the financial implications of the lawsuits, the bond, $500 million bond to build the water surface treatment plant, all of that stuff, and say, where does it end? We have a way to turn these problems off. Let's do it.
Love it.
So one more, also we have a way to study them. That's the angle I like a lot, is we've got a very unique opportunity, very unique setup for the San Jacinto River Authority or Lone Star to go back and put in place 3 core stations on 3 faults in order to look at local and regional effects of faulting in a managed area that we know has been undergoing subsidence at this rate until we open the pipeline. We've got a wonderful laboratory if we can ever get attention to it. To that end, I've suggested to several parties in B, we ought to approach the Woodlands High School and try to get them to run a course in geology, spatial positioning. Instead of turning out air conditioning people, we ought to be turning out paraprofessionals that know how how GPS spatial positioning works. That could be a valuable skill to have if we're looking at subsidence across an area. You need people who can go out with GPS systems and get reliable, not just X, Y, and Z, but know how much time I need to spend at a particular location to get a really accurate Z.
How much does a core station cost?
Oh, I don't know. NSF provided these to the University of Houston, and they needed places to put them where I haven't put up those 3 high schools. But that's not even part of it, Laura, because how much does it cost to have 3 years worth, 45 years worth of data on that particular reference station? It takes more than 2 years just to understand the cyclicity, what the annual position really means.
Mhm.
And I've got 5 years worth of data. Well, we've got 5 years worth of data on those core stations. They're reference stations. They're not the experimental where we collect the experimental data, but they're there to kind of really understand what's happening at a baseline level.
Mark, here's what I'd like you to do, if you agree. Send me all your stuff and let me work on it for a while. Laura, you do the same. Let me try and put it into a PowerPoint that is self-explanatory for people.
I'm going to send it to you at a PowerPoint level. If you have trouble manipulating a PowerPoint slide set, if you have trouble manipulating it, I've got all this stuff on Keynote.
Perfect.
Okay. I'll send that at the conclusion.
Yeah, I've got Keynote too, so you can send
Yeah,
it.
I just figure you're a Mac guy.
You don't have to translate. But let me finish the thought. One of the things that I've learned about PowerPoints over the years is that you always should state the conclusion of the slide in the title of it. One slide communicates one thing, and that needs to be in the title of the slide. Boom, go to the next slide, and you build the thing like that.
My turquoise chart in the top says subsidence stopped.
Yes.
Mhm.
No, I agree. I agree.
Yeah. So let me work on it like that. And before I publish anything, I promise I will get back to you guys and we'll go over it together and you'll have a chance to, give your input. And before I publish anything, we'll all be happy with it.
Yeah.
Okay.
Also consider breaking it down into several modules. I mean, we're talking, there's some people that might be interested in really seeing the proof case for there being an active fault where they said it wasn't. There are other people that might be interested in just lay people that be interested in, I got my kid in the high school, I don't want that.
Yeah, should he wear a life preserver?
Yeah.
There
my car.
Right.
There are so many issues related to this stuff. Every time I publish something, I see my readership scores go up and down. It's like a roller coaster. The amount of people that engage with any given post depends on how many people are affected by it. For instance, the last few days, I've been doing a series on buyouts in the Lake Houston area. They take an ungodly amount of time. These are places that have been flooded repeatedly and destroyed. It started with building, as we're trying to buy out one set of townhomes, the developer's building another set of townhomes even closer to the river than the ones we're now buying out. And it takes 3 or 4 times longer to buy out these things than it does to build new ones. It's a Chinese developer that's coming in, and
it's after new. But talk to Laura about that, because where the Big Barn Fault crosses I-45, crosses several subdivisions. If you go to a map and look at it, there are lots in a subdivision that have no house on it, and that perfectly matches where the Big Barn Fault crosses through. And I'm sorry.
No, that's amazing. The point of that story was that because fewer people are affected by buyouts than they were by flooding in general, the readership for those things went down. What we need to do is find a way to embed hooks into this story that touch a lot of different audiences to expand the appeal. So send me what you got. Let me digest it and work on it. It may take a few days.
So I'm a political person, I suppose, unfortunately. And what I would like to do is increase public input to a GMA 14 meeting. And it doesn't have to be this particular one, but there is one September 16th at 10 a.m. that's not during, or it's during a work day. So that's not good.
Who is GMA?
Groundwater management area, and that is a board, and the way I see it, it's above Lone Star. One member, Samantha Ryder of LSGCD, is on the GMA 14 board, and that's the board. I think he met with John Martin. He's the president of GMA 14.
I've been introduced to John Martin
Okay.
Bruce Reiser sent me an introduction to John Martin, and as I wanted to kind of find so I need to find
President of GMA 14, and there's a lot for me still to find out about that.
Okay.
For example, there's case law where property rights win over the GMA in any kind of lawsuit. And so I think that I may have heard someone say things like the GMA members are worried about getting sued themselves. They are not well financed. I don't know that they even get a stipend for their meetings. I think that they should get that. I mean, the GMA 14 physical area before the coronavirus, these people had to drive 3 hours to get to a meeting. So now they're on WebEx or something. But I have heard that 4 of the members of the 5-member GMA 14, and Turco's on that board, but he can't vote on DFCs. He's just a subsidence district member, so he attends those meetings. And I think there's another guy, Pudge Wilcox, who doesn't have a vote, but he attends. But this board is going to be the one that says to LSGCD, your DFC of 111,000 acre feet a year is okay. And I think that politically, LSGCD basically owns the GMA. The GMA has to do whatever Lone Star wants. That's the gist that I get from just talking.
I'll go back to, I'll try to settle up with Bruce Reiser. I owe him a presentation at some point in time, make him knowledgeable in this, because he's taking my story to John Paul Boucher. I'm sorry, Bob, I feel like Laura and I are kind of talking about things that are of common interest on this side of the table. I agree with you. I'm going to, as soon as I hang up in a minute, I'll forward you, and I've owed this to Laura for 24 hours, a copy of this slide presentation, basically. I can provide you all kind of additional slides as you need them, but I think this would be a good start to kind of be in the storyboard what it is you'd like to see.
Yeah, that'd be great. And Laura, if you could do the same. Before we sign off, and I've got another meeting with the Harris County Flood Control District in an hour that I got to start getting ready for. But the thing is, on this groundwater management area, I thought the deal with that was that all of the subsidence districts within the bigger area had to agree on what each district could pump. Is that true?
I agree. That is a good characterization of their role. Yes. But so there was a meeting when they put together 3 possible runs that they were going to do, model runs of how much they could pump out, and they moved forward with selecting 3 model runs, and one of them is the most aggressive one, is 111 or 12 whatever acre feet per year. And the fact that that GMA board passed that motion that 112 acre feet per year is something that they would be willing to look at. They were willing to do that model run. I think that implies then that they would pass that run when the results come back from Interra. I get the impression that these guys are going to win this. And for the biggest reason I get that impression is there is so much case law all around the state of Texas where GMA, whatever the number is, says, no, you can't do that. That would cause subsidence. You're pumping too much groundwater. The GMA always loses. Some farmer guy always wins. He owns that property and he has a right to pump whatever he wants. So all of us are just a bunch of ants, and we'd like to do the responsible thing that's best for the people of Texas, but the state of Texas always says property rights prevail. And that's that's what I get out of the way we work in the state.
We've got the same thing, same issues, and property rights with developers that want to build in the floodway of the San Jacinto.
Yeah,
it's crazy.
Yeah.
Property.
Welcome to Texas.
There was a guy last year that wanted to build a 50-story high-rise in the floodway of the San Jacinto here in Kingwood.
Wow.
And during Harvey, the area where that building would have been received 22 feet of water. It was 22 feet above the normal.
Yeah.
I'd like to know
no way to evacuate that building.
Yeah. What's my right not to subside? I'd like, if we were going to talk about property rights.
Well, the thing, again, the little story I think it might have some traction is, wouldn't it be nice if we could actually empirically determine what happens when you pump that 11,000 feet of water out of the aquifer? What does that mean in terms of surface subsidence?
Yeah, that'd be a good thing to know.
Yeah, if we know that, and how far does that subsidence extend? I tell you, we have a very unique situation right here in Montgomery County that a lot of the world doesn't have access to. It'd be hard to reproduce. And we could get that information quicker than anybody else in the world because we've already got 3 or 4 years worth of data stacked up on 3 faults and all 3 core stations on 3 faults, all in this common area. That's awesome potential for understanding what the relationship is between groundwater extraction and surface subsidence. And therefore faulting as well.
Let me ask you another question. How would you feel about drawing the SJRA into this circle? I mean, they have a vested interest in surface water. And I've got a relationship with Jace Houston and Chuck Gilman up there, and a couple of the board members that live here in Kingwood, like Karen Cambio, who's also on the staff of Congressman Dan Crenshaw. There are a lot of connections here, people who would like to see the subsidence stopped. Do we not draw them in at this point?
I would say draw them. I've done everything I can. I've done conversations with everybody associated with this problem. I wrote Samantha, a writer, a letter thanking her for arranging for the board members to attend my presentation. Oh, by the way, I am concerned that there's not just this excitement over understanding actually the empirical relationship between water extraction and surface subsidence, because I thought that would have been of high interest. And then I pointed out that, maybe we could do some things like get the high school involved so we could generate a cadre of low cost geodesists that could help us measure annually or even more than that. You send a class of high school kids out to collect this data if they know what they're doing. And we really have a good, tool for understanding subsidence in this area.
You know who might be more knowledgeable, and I don't know if anybody here knows her, but Kathy Turner Jones used to be the general manager of Lone Star. And as soon as this Simon Cicada board of 7 got on board, They fired her and she moved to the Dallas area. I have heard from someone, and I think I might remember who, but she is willing to converse because she feels really bad about our area and what's happened.
You have a way of getting a hold of her?
She'd be a good person to bring in too.
You have a way of getting a hold of her? I don't mind calling her.
But I originally got interested in this idea, Laura, when Jace called me and he said, I'd like to brief you on something related to flooding. And I went up there to their headquarters at the dam and spent half a day with them. He and Chuck Gilman took me through a number of presentations that they had developed that were very consistent with the direction you guys are going. They have a real vested interest in seeing subsidence reduced. And they have a lot of data. Now, the reason I asked the question was because in your presentation, Mark, you seem to position the SJRA as an adversary when it came to, they were the data deniers that at this point.
Quite contrary, they've given me access to all their data. They just, their geologist has just said, I don't, he's wrong. Not for any reason, but just, there's no fault here, period.
Yeah. Well, you made a very good point when you said that the minute they put that pipeline across there, the subsidence stopped, and that's why the measurements are so small. But if they start pumping again like crazy and nobody's buying SGRA water, they could start and that pipeline could rupture, like you say.
Jace caught that. Jace is caught. Jace knows that probably even better than I do right now. As of last Monday, I did a presentation for Jim Stinson and Jace and your friend Neil Gaynor. And so I think they're on top of it. I think we've got them in the circle. It's just, we got this thirst for groundwater that it's got to be diverted somehow.
The state of Texas has given the thirsty ones the power. They are just an LSGCD board, but they have ultimate power. And their elections are going to be this November, and no one is running for the board. They're scared of the Tea Party.
Shit.
So they get 2 more years as this board.
Well, I've got to jump off here.
I do too. I'm sending you a slide presentation. Laura, stay in touch.
Yeah, okay.
You're the ringmaster.
Mark, thank you so much for that. It was really a pleasure meeting you. And I look forward to working with you some more. You are the citizen activist that should be the model for everybody.
Well, when we get the coronavirus antidote or a vaccine, we'll celebrate.
Yeah, Sputnik 5.
Okay. Thank you, guys.
Bye-bye. Take care.
Bye-bye.